In the last video, we talked about the distinctions between rule-based learning and example-based learning. The reason that neural networks and deep learning are useful is that they can be trained using past examples and then make predictions about the data that are not in those examples used for training. We talked about this very simple neural network and the calculations involved in this neural network. So to make our discussion slightly more interesting, we were using this neural network to model the relation between the inputs, which are the number of man hours for making a YouTube video, and the content type of that video, and also the output, which are the average number of views and likes per week, right? So in order to compute the output from the input, we need to assume some random values for the weights. And for this neural network, we have 12 weights in total. Once we have a set of values for the weights to compute the output from the input, the calculations only involve additions, multiplications, and the application of a certain nonlinear function. And today we're going to look at a specific form of that particular nonlinear function called the sigmoid function. And those assumed random values for the weights are certainly not the correct values. They are not the correct values, right? They are just random numbers. They are not the correct values. So the computed output will certainly be different from the actual number of views and likes per week for a previous video that we have collected, right? We talked about the possibility of creating a feedback mechanism that allows the neural network to automatically adjust those weights, based upon the differences between the computed output and the actual output for a video in our training examples. So in this video, we will only talk about how to compute the output from a given input. Suppose we have a previous video, right, which took about 12.5 man hours to make, and the category of this particular video, of this video's content, is education. The average number of views per week is 10, and the average number of likes per week is 1, right? So that's the input and the output for a previous video that we have a record of, right? So this is one piece of training data, right? One piece of example that can be used for training this particular neural network, right? The category of the video's content is not really a number, right? It's a text description, but we can associate a content category with a unique number. Suppose we have 10 categories for the contents in total, right? The first content type is news, and we assign the integer 1 to this category. And the second content type is, for example, movie trailers, and we assign the integer 2 to this category, and so on and so forth, right? So we can separate all videos into like just these 10 categories, 10 content categories, and assign a unique number to each category, right? So let's assume that we assign the content type education the integer 4. As long as we are consistent about this association between content type and integer for all the videos in our training example dataset, the neural network will automatically adapt to this association. After the neural network is trained, when we try to use this neural network to make a prediction about a video that's not in the training dataset, then we must still follow exactly the same content type integer association, right? So if you are using the number 4 to represent education, for example, right? Then when you try to make a prediction about a certain video, if that video is also education, then you must also use number 4 as the category number for that particular education video, right? You have to be consistent both during your training and also during your prediction stage, right? Now let's look at how to write a computer program to actually calculate the output from a given input using this neural network, right? We talked about those equations in abstract forms, right? But now let's try to turn those equations into a concrete computer program. If you haven't learned about computer programming before, it's okay, right? You can still carry out all the calculations by just using a hand calculator for this particular very simple neural network, right? And if you are interested in learning how to write computer programs, I also have a sequence of videos that teach you how to write computer programs in MATLAB. It's a quite popular programming language for technical computing, right? It's used very widely by engineers and scientists. For professional programmers, sometimes they use C, C++, Fortran, Java, right? I have videos for C, C++, and I will make more videos about Java later on. Right? But here we're actually looking at a computer program that's written in a language that's called Python. It's a high-level computer programming language, right? And it's called Python. If you don't know the Python language, it's okay, because I will upload some videos about Python later on. Right? The reason that we are using the Python language here is because in later videos about deep learning, we will be using Tensorflow, a software package, a software library called Tensorflow, which is actually a Python library for deep learning, and it is developed by Google. So we're going to be using Tensorflow for dealing with as a tool for demonstrating concepts in deep learning. It's a very good package. It's a very good software package, and it's developed by Google. It's very well designed. And it's very efficient, and it allows you to actually run your neural network not just on ordinary CPUs but also on graphic processing units, right? GPUs. And if you have a collection of GPUs in a sort of organized in a distributed way, not just in one machine but in multiple machines, TensorFlow can also allow you to run on those kind of hardware setup. So later on we will use TensorFlow, but for now, let's look at this particular program. Right? You don't really need to be an expert in Python to understand what's actually happening in this piece of code. Right? As long as you understand English, this piece of code will make some sense to you, right? Because Python is a very high-level language. It's actually already very close to ordinary English. Right, but you do have to pay attention to a few things in this kind of computer programs. Right. So the first two lines, in the first two lines of this piece of code, I'm just actually importing. I'm just importing computer programs from some pre-existing libraries into my own program. So in my own program, I can use those computer programs written by other people and have been packaged into those libraries. Right, so here I'm just importing those pre-existing libraries, so I can use those functions defined in there. And this line here, is actually generating the random numbers. This line is actually generating the random numbers for the 12 weights used in this neural network. and these 12 weights are organized into 2 layers, right? So the weights are associated with 2 layers. So that's why the first number here is 2. And then at every layer, we have 2 logits, right? At every layer, we need to compute 2 logits. And that's why the second number is also 2. And then every logit has to use 3 weights. So if you look at this logit, there are 3 arrows pointing into it. This logit also has 3 arrows pointing into it. And then this logit also has 3 arrows pointing into it. And this logit also has 3 arrows pointing into it. So that's why it's 2, 2, 3 here. So if you multiply all the numbers together, 2 multiplied 2 is 4. 4 multiplied 3 is 12. So that's exactly 12 random numbers. And all those 12 random numbers are being stored into a variable that's W. That's called W, right? So W is like a big container, right? It's a container for numbers, right? And inside of this container, we have like 12 random numbers inside of it, right? It's just W is just a container for containing those 12 random numbers, right? You can think of it like that. And then here we are actually defining the nonlinear function that converts the logit Z into the output Y. And this nonlinear function we are using here is the so-called sigmoid function, right? So when we talked about the internal structure of a neuron, for this particular nonlinear function, we have quite a few choices, right? And sigmoid is one of those choices. So here we have made a choice to use the sigmoid function as our nonlinear function to convert the logit into the output of that particular neuron, right? So if you have not seen the sigmoid function before, it actually looks like that. So this is actually the mathematical form of the sigmoid function. So the y, the output y, equals to 1 over 1 plus this exponential minus z is actually e, the number e, which is about a 2 point something, right? The number e to the minus z's power. And z is what? Z is the logit, right? So if you try to make a plot of it, it's going to look like this kind of S function, this kind of S curve, right? It's pretty flat over here, and then it goes down, and then becomes flat again. And the range of the variation goes from 0 to 1, right? So the minimum value is like 0. The maximum value of the function is like a 1, right? So that's what the sigmoid function actually looks like in the mathematical form. So in this Python code, we just directly translate the mathematical formula into computer codes, right? So here mp.exp is actually the name of this particular exponential function, right? You can think of mp.exp just as exp. It's just the exponential function, and the name of the function is called sigmoid, right? Def is just a Python keyword. Here we are defining a function with the name sigmoid, right? And then this function is going to take one input, that's z, that's our logit, right? And then it's going to return one output. And this output is what? This output is 1 over 1 plus e to the minus z's power, right? And then the next function, which has the name predict, actually calculates the output, right? Which is the average number of views and likes per week from the input, right? Which is actually the number of man hours x1, and the category code for the content type, which is x2, right? Don't forget, we also have a bias node, which has a fixed value in it, which is x0 equals to 1, right? So with all those things prepared, we can actually start to compute the logit now, right? The first logit we're going to compute is z11, right? So here z11 is computed on this line, That's Z11. The first one here is actually corresponding to the layer index 1. Right? And then the second one here actually corresponds to the neural index 1. That's the subscript. Right? So the first one actually is the superscript. The second one is actually the subscript. Right? And Z11 actually equals to what? Z11 equals to this summation, right? Summation. The summation of the inputs x0, x1, and x2, right? Multiplied with their corresponding weights. Right? That's exactly this formula here. So x0 is multiplied with its own corresponding weights. And then x1 is multiplied with its own corresponding weights. Those weights were defined here. Right? Remember that W used here is actually a container with 12 random numbers in it, right? And those 12 numbers are organized into 2 layers, and every layer has 2 logits, right? And every logit uses 3 weights, right? So those numbers in the square brackets is just a way for you to actually retrieve those 12 numbers in a specific sort of order that's kind of related to the layer number, the logit number, and the weight number, right? That kind of a so if this kind of numbers inside the square brackets confuses you, it's okay for now, right? Because we're going to talk about Python in a lot more detail later on, right? But for now, you can just think of those numbers inside of the square brackets just like those subscripts and superscripts, right? So the first number is actually the superscript. The next 2 numbers are the subscripts, actually. So you can think of it like that. Think of it like that, right? And that's Z11. Z11. And then Z12. Z12. The first one is the superscript of the layer index. The second two, the second number 2 is actually the subscript of the neural index, right? It's computed using a similar formula, right? Except that the weights are different. Right? Here we are actually retrieving a different set of numbers from that W container. Right? We're retrieving 3 different numbers. You can sort of compare it, right? The indices are different. The numbers inside of the square brackets are different, right? Once we have talked about the arrays in sort of in the Python language, you understand why it's actually organized this way. But for now, you can sort of see that it's actually 3 different weights. Right, 3 different weights. Those 3 different weights are actually associated with these 3 blue arrows. So these 3 weights. This one, right? These 3 weights. When we computed Z11, it's these 3 weights. Right, this weight, and this weight. No, this weight, and this weight. Right. When we computed Z11, it's these 3 arrows. Right, these 3 arrows. So the weights associated with these 3 arrows is this one, and then this one, right? So now we are computing Z21. The 3 arrows are this one, and this one, right? So it's actually this number, this weight, and then this weight, right? So that's how Z11 and Z12 are computed, right? The inputs are the same, right? But the weights are different. And once we have Z11 and Z12, Z11 and Z12, that's the 2 logits, right? We can use that nonlinear function to compute Y11 and Y12 now, right? So Y11 equals to sigmoid Z11, right? Y11 equals to sigmoid Z11. Sigmoid is what? Sigmoid is exactly the function that we just defined above here, right? So here we are sending Z11 that we computed here into this sigmoid function that we defined here. And then the output of this particular function is going to be Y11. Right? That's why we are assigning it to the number to the variable Y11 here. Right? The same is true for Z12. So if we send the Z12 to that nonlinear sigmoid function, then the output of it is going to be Y12. That's Y12, right? And then don't forget, there's also a bias node Y10 here. Y10 has a fixed value of 1 here, right? So now we have the outputs from this particular layer, from layer 1 now. The 3 outputs, right? And now we can compute the logits for layer 2, right? Z21 and Z22. So Z21 requires the input from this neuron, and this neuron. So it's Y10, Y11, and Y12, right? Y10, Y11, and Y12. Right? And then the weights associated with these 3 arrows are just these 3 weights. Right? Again, we have to retrieve these 3 weights from our W container, which has the 12 weights inside of it. But now it's for layer 2 now, right? It's for layer 2 now, and so those indexes, those numbers in the square brackets is again different, right? Different from all the previous W's, right? All the previous indices that we have used above here and here, right? These 2 lines, but the indices here are different now, right? And then Z22. Again, we're going to have to use Y10, Y11, and Y12 as inputs, right? But the weights are different. The weights are different. Those are different numbers from the container W here. Here, we define here, right? And then once we have Z21 and Z22, these 2 logits, again, we can compute Y21 and Y22 by using the sigmoid function. And Y21 and Y22 will have different values. Will be our output, will be our computed output, the output computed by this particular neural network, right? And Y21 and Y22 will need to be compared with the actual number of views and number of likes per week, right? And we can run this particular program. We can run this particular program inside Python and find out the performance of our neural network, how good it actually is, right? Let's run it in Python. So I'm running on Mac. If you are on a PC, then it's a different kind of environment. But how do you actually set up those environments so that you can run Python codes, right? We'll talk about that in separate videos. So let's try to run this program inside Python and find out the performance, right? So here we have invoked the Python interpreter, right? And so here I have actually imported the 2 functions, the sigmoid function and the predict function that I have written by myself, right? And then the weights. Let's look at the weights, right? The weights are just the random numbers, right? And then it's organized into like these 2 sections, right? Each section is for 1 layer, basically. The weights associated with 1 layer, and this is for layer 1. So you have 6 numbers, 6 weights for layer 1, right? And then these are for layer 2, another 6 numbers, right? And then for each layer you have like 2 rows, right? So these 3 numbers are for these 3 weights, and then the next 3 numbers are for these 3 weights, right? And then for layer 2, the 3 numbers here are for these 3 weights, and then the next 3 numbers are for these 3 weights, right? So that's the random numbers produced just by a random number generator. So that's going to be the W that will be used in the predict function, right? So now let's call the predict function. Let's call the predict function. Our input is 12.5, right? 12.5, and then the category code is 4, right? And then let's see how will the that's the output produced by our neural network. So the neural network is actually predicting that for this particular video that took 12.5 man hours to make, and in category code 4, the average number of views per week is like 0.8, and then the average number of likes per week is like 0.87 something, right? Which is way off, which is very different from the actual output, right? The number of views per week for this particular video is 10. This one gives like a close to 1, and then this number close to 1, right? But maybe this number is sort of closer, right? But this number is like way off, right? And the reason that the predictor function is not able to actually very accurately sort of predict or reproduce the actual number of views in weeks is because those weights are just the random numbers. They are not particularly tuned to actually make this kind of a association between the output and the input, right? So the question now is how we can actually adjust those weights, how we can actually make adjustments to those weights so that the differences between our model prediction, the neural network's prediction, and the actual output, can become smaller and smaller, right? And the procedure for doing that is called backpropagation, right? And we'll talk about backpropagation in the next video.